Deep learning is a subset of machine learning that uses artificial neural networks to model and solve complex problems. It involves training a neural network with a large amount of data to learn and improve its performance over time. Deep learning is particularly useful for tasks that involve unstructured or complex data, such as image recognition, natural language processing, and speech recognition. Here's a real-time example of deep learning in action. One of the most common applications of deep learning is in image recognition. For example, consider a security camera that is installed in a busy public place, such as a train station. The camera captures video footage of people walking by, and the goal is to identify any suspicious activity, such as a person carrying a weapon or behaving in a threatening manner. To accomplish this task, the video footage is fed into a deep learning model that has been trained to recognize different objects and activities. The model consists of multiple layers of artificial neurons that are connected in a hierarchical manner, allowing it to learn features at different levels of abstraction. The model is trained using a large dataset of labeled images, and it learns to recognize patterns and features in the images that are associated with different objects and activities. As the camera captures new video footage in real time, the deep learning model analyzes the images and makes predictions about the objects and activities that it sees. If the model detects any suspicious activity, it can trigger an alert that prompts security personnel to investigate further. This is just one example of how deep learning can be used in a real-time setting to automate the process of identifying potential threats or anomalies. Other examples include voice assistants like Siri and Alexa, which use deep learning to recognize and respond to user commands, and self-driving cars, which use deep learning to recognize and interpret visual and sensor data in real time to make decisions about how to navigate the road. There are several deep learning tools available for developers and data scientists to use, depending on their specific needs and preferences. Here are some of the most popular deep learning tools. Tensorflow, developed by Google. Tensorflow is an open-source platform for building and deploying machine learning models, including deep learning models. It provides a wide range of tools and libraries for building and training neural networks, as well as APIs for building custom models. Keras is a high-level neural networks API that can run on top of TensorFlow, CNTK, or Theano. It provides an easy-to-use interface for building and training deep learning models, with support for convolutional networks, recurrent networks, and more. Pytorch, developed by Facebook. Pytorch is an open-source machine learning library that provides support for building and training deep learning models using dynamic computational graphs. It has a Python-based interface and supports GPU acceleration for faster training. Caffe is a deep learning framework developed by Berkeley AI Research Bear that is specifically designed for computer vision tasks. It provides a simple and efficient interface for building and training deep neural networks. Mxnet, developed by Amazon. Mxnet is an open-source deep learning framework that provides support for building and training deep neural networks using a variety of programming languages, including Python, R, and Scala. It is designed to be highly scalable, with support for distributed training across multiple GPUs and multiple machines. These are just a few examples of the many deep learning tools available to developers and data scientists. Each tool has its own strengths and weaknesses, and the choice of which one to use will depend on the specific requirements of the project. Here are some live examples of deep learning in action. Self-driving cars. Deep learning is used to train self-driving cars to recognize objects and navigate roads. For example, Tesla's Autopilot system uses deep learning to identify lane lines, stop signs, and other obstacles. Virtual assistants. Deep learning is used to power virtual assistants like Siri, Alexa, and Google Assistant. These assistants can understand natural language commands and respond to questions and requests. Image recognition. Deep learning is used to identify objects in images. For example, Google Photos uses deep learning to identify faces, places, and objects in your photos. Speech recognition. Deep learning is used to transcribe speech into text. For example, the voice search feature on your phone uses deep learning to transcribe your voice commands into text. Machine translation. Deep learning is used to translate text from one language to another. For example, Google Translate uses deep learning to translate text between over 100 languages.